Hello everyone. Today we will discuss about some problems from electromagnetic theory. Some problem from TIFR-NET, GATE, JAM, JEST in latest year problem. We discuss the solutions of problems in this year which are came to the year 2024. Now let's see the question and corresponding answers. The first question was asked in TIFR 2024 December paper from EMT. Unpolarized light of intensity 20 watt per meter square incident on a two perfect polarizers. So it is the first question. So the diagram was, if we draw the diagram, the unpolarized light was given. Let its intensity will be I0 and it is fall on two set of polarizer. Let it is P1 and second is P2, and the axis of this polarizer angle was given. The first polarizer axis was given at 55 degree with the vertical. So its angle will be 55 degree. This was given 55 degree, and for the second polarizer the transmission axis will be 100 degree with respect to the vertical. So for second polarizer the angle will be 100 degree. The intensity of the unpolarized I0 is given here. I0 is given 200 watt per meter square, and we are asked to find the intensity of the transmitted light I. If we denote I0 and here I1 and next the last intensity I2, then I2 will be find here according to the question. So we use here the Malus law concept. So after passing the first polarizer, the intensity of the transmitted light I1 will be I0 by 2, which was the special case of the Malus law. Here we use Malus law. So I1 will be 200, which was given by 2 watt per meter square, equals to 100 watt per meter square. Next, we are required to find the angle between two polarizer. The angle between two polarizer axis, will be if we denote this by theta, which was equal to, there this is 100 and this is 55. So we subtract between them, which will be 100 degree minus 55 degree equals to 45 degree. Now again using Malus law concept, here I1 light is after passing P1, it was plane polarized, and again the third case it is plane polarized also. Malus law using the intensity of the transmitted light after P2, I2 will be I1 cos square theta, where theta is the angle between two axis of the polarizer, cos square theta. I1 equals to given 100 watt per meter square into cos square 45 degree watt per meter square. which will be 100 into half watt per meter square equals to 50 watt per meter square, which was given in the option A. So the right answer of this question was option A, 50 watt per meter square. Next, it is also from EMT question. Our problem 2. Here, a incident light is reflected from a glass which was immersed in ethyl alcohol, and the refractive index of the two medium was given, and we should find the angle of the incident light with respect to transmitted through the plate. So if we draw the diagram, it is glass plate which was immersed in the ethyl alcohol medium. A unpolarized light falls on the glass plate which was UV. Some of its part which is reflected back, which is plane polarized, and some of it is transmitted. The angle is theta and the transmitted angle is R. So here, from the condition of the Brewster law, we can calculate the Brewster angle. So here, the reflection is found to be completely linearly polarized. So here from question we see that the reflection light is completely plane polarized. So for the condition, from the condition of Brewster law, here the reflected light will be plane polarized. Reflected light will be plane polarized when the tan of incidence angle, tan of theta p, which where theta p is the Brewster angle, equals to refractive index of the glass by refractive index of the medium. So from here we can calculate the theta p. So theta p equals to tan inverse, the refractive index of two medium was given, Ng value is 1.65 and Na is the 1.36. If we calculate this, we get the theta p value is the 50.5 degree. But in the question, we are asked to find the angle at which the incident light would be transmitted. So we should find this angle R. So R will be find. This is the question. But here we get the value of theta p. So next we use the angle between transmitted ray and reflected ray. So from the Brewster law concept, we know that the sum of theta p and R will be 90 degree. So we know that since theta p plus R equals to 90 degree, from this we can calculate R equals to 90 degree minus theta p. So calculate after 90 degree minus 50.5 degree, which was 39.5 degree, which is the value of the R. So the option matches with option A, 39.5 degree here. This is the right answer of this question. So here we use the Brewster law concept here. Next question is comes in the 2024 TIFR exam. This is a smartphone emits electromagnetic radiation with power 1 watt. Now we are required to find the RMS magnetic field. So the data which was given in this question was the power and the distance from the source. So firstly we are given the data power equals to power P equals to given equals to 1 watt and distance D is given 25 centimeter, and we know that the intensity I equals to half of C epsilon 0 for free space, half of C epsilon 0 E0 square, and in the form of magnetic field is it half of C epsilon 0 CB0 whole to square. Next we get that I equals to half of C cube epsilon 0 B0 square. Now we are required to find the RMS value of the magnetic field. So BRMS equals to B0 by root 2. So C cube epsilon 0 into BRMS whole square. Since BRMS equals to B0 by root 2. Now we know that power equals to intensity into area. Intensity into area. Now P equals to I into A. After putting the value C cube epsilon 0 BRMS square into 4 pi d square, which was the area from the source. So BRMS equals to P by 4 pi epsilon 0 C cube into d square whole to the power half. After calculating this value, we get 7.3 into 10 to the power minus 8 Tesla. If we analyze this answer, we get that 0.73 into 10 to the power minus 7 Tesla, which was nearly equals to 10 to the power minus 7 Tesla. Now we match the answer with the given options, which matches the option A here. So the right answer of the question was option A, 10 to the power minus 7 Tesla. Then the next question asked from the one dimensional infinite long wire. The charge density lambda was given. We are find to the potential difference from 2 points. So here we use the Gauss's law of the electrostatics. So here a long infinite wire was given. A long infinite wire was given, which charge density was lambda, and 2 point rho plus a and rho, and potential corresponding this point V of rho plus a and V rho. Now we are asked to find the delta V. So here we use the Gauss's theory in electrostatics. So Gauss's theory in electrostatics, we know that for infinite wire the electric field at distance r E equals to lambda by 2 pi epsilon 0 r, and direction will be r cap. Now potential difference delta V equals to V2 minus V1 equals to minus 1 to 2 E dot dr. So from the given question, delta V equals to V of rho plus a minus V of rho equals to integration limit rho to rho plus a, after putting the E value lambda by 2 pi epsilon 0 r into dr, we get the delta value option. Delta value will be minus of lambda by 2 pi epsilon 0 ln of rho plus a by rho equals to minus lambda by 2 pi epsilon 0 ln 1 plus a by rho. Now in this question, a by rho is less than 1. A is less than rho, so a by rho is less than 1. So ln 1 plus x here equal to ln 1 plus x or 1 plus a by rho nearly equal to x or a by rho. So the final answer will be delta V equals to minus lambda by 2 pi epsilon 0 a by rho, which was the final answer. So here with option message with option 2 here. This is the problem 3. Problem 4. Next, the question from JAM 2024. The electric field of a electric wave is given. Electric field was given. Find the value of the A. So here we are required the linear form of Maxwell equation. So first Maxwell equation was del dot E equals to 0. Now this operator del replaced by ik, where I is the propagation vector. So we get k dot E equals to 0. We use this question, this equation. Now from the question we get the k value, where k dot r minus omega t equals to, given in the question, omega t plus ax minus 600 y, or k equals to minus of ax plus 600 y. So k dot equals to 0. Now put the k and e value, we get minus ax plus 600 y dot 4x plus 3y equals to 0. After calculation, we get minus 4a plus 1800 equals to 0. Now get the a value is equals to 1800 by 4 equals to 450, 450, which was option here A. So the right answer of this question was option A here, from the value of the A value. Next the question from the laser question here. This is the problem 5, and next the 6th problem. A laser beam whose intensity was given in our problem, and we should find the A value. Now power is given here. Power P equals to 15.7 milliwatt, and diameter of the laser source equals to 4 millimeter, and the magnetic field B0 equals to A by root under epsilon 0 C cube. Now from the power formula of the laser source, power P equals to intensity into area, which will equal to half of C cube into epsilon 0 B0 square into area is pi of R square, pi of D by 2 whole square equals to half of C cube into epsilon 0 into the value of B0 here, A by root under epsilon 0 C cube. So put this value here. So here A square by epsilon 0 C cube into pi D square by 4. So from this is cancel out, and A square by 8 into pi D square, which was the power. Next, the value of the A equals to 8p by pi D square. So A will be root under 8p by pi D square equals to 8 into 15.7 into 10 to the power minus 3 by pi of the value of D was given 4 millimeter square. Now after calculation, we get the value of A equals to 50. So the option of the value of the A was given in the option A here. So this is the sixth problem of the EMT question. In the next part, we will see the remaining questions. So thank you. Let you see in the next part.